Hi, welcome to Hi, welcome to Naming Binary Ionic Compounds for Type 2 metals. This video is going to deal with naming only the binary ionic compounds that contain Type 2 metals. Remember, Type 2 metals are everywhere on the periodic table except where the Type 1 metals are. So everything but groups 1, 2, and the stair step. Okay? Any other metal on the periodic table is a type 2 metal. Now, what exactly does that mean? That means, remember, that it can lose different numbers of electrons. So, for example, iron can be a +2 metal or a +2 charge or a +3 charge. When we name it, how do we know the difference? With our type 1 metals, we didn't put anything in there that told the charge because they always had the same charge. But with a type 2 metal, it can have different charges. Well, remember when we named the ions, we put Roman numerals. That told the charge. We do the same thing when we're naming the compound. So, let's go ahead and do one. FeBr3. You've got those two questions that you still have to ask yourself. Question number 1, is it an ionic or a covalent compound? Well, iron is a metal, therefore this is an ionic compound. And then because it's ionic, we have to ask ourselves question number 2. Does it contain a type 1 or a type 2 metal? Well, iron is not in group 1, group 2, or in the stair step. It's right up here. That means this is a type 2 metal. So type 2, that means we have to actually put the charge on this iron in the name of the compound. Well, we have to figure out what it is. The way you figure it out is based on what it's partnered with. So what I know is that my iron has some unknown charge, but it's partnered over here with 3 bromides, 3 bromide ions. And what is the charge on a bromide ion? Well, bromide ion comes from bromine over here in the halogens, so it has a -1 charge. So bromide has a -1, but remember I have 3 of them. So I actually have this. Well, if I have a -3 charge on my anion, remember that the entire compound has to be neutral. That means that the charge on this iron must be a +3. That's a little difficult to see. +3. Okay? So, knowing that my iron is a +3, I can go ahead and name my compound now. We're going to do this the same as we named the type 1s, just that now I have to specify iron 3 in order to tell people that this has a +3 charge, and then bromide. So again, nothing in the name says anything about how many bromides that are on here. This 3 is telling me the charge on the iron. Remember, this just tells me that, okay? So let's go ahead and do another one. Okay, MnO2. Again, we have to ask ourselves those questions. Question number 1, is it ionic or covalent? Well, manganese is a metal. therefore it's ionic. Because it's ionic, we have to ask ourselves question number 2. Does it contain a type 1 or a type 2 metal? Well, manganese is not in group 1, group 2, or the stair step. Therefore, this is a type 2 metal. Remember that what that means is I have to have Roman numerals in the name of the compound. So, we have to figure out what the charge is. Well, again, I have manganese with this unknown charge, but I have 2 of these oxides. And what is the charge on an oxide? Well, oxide is right here, so we're going to gain 2 electrons, giving it a -2 charge. If overall in this compound I have -4 from my anions, that means that this one manganese must be what charge? A +4. So now I know that my manganese is a +4, I can go ahead and name my compound. Manganese 4, because that's telling me that the manganese is a +4, and then oxide. So this compound is manganese 4 oxide. Let's go ahead and do one that's a little more complicated. Let's pick one that actually has more than one of the metal in it. Cu3P2. Question number 1. Is it ionic or covalent? Because copper is a metal, it's ionic. Question number 2. Does it contain a type 1 or a type 2 metal? Well, copper is not in group 1, 2, or the stair step. It's a type 2 metal. That means we need Roman numerals in the name of this compound. So, what I have now is 3 of those copper ions and 2 of these phosphide ions. Well, what's the charge on the phosphide ion? Because I don't know what it is on the copper. Well, the phosphide is in the nitrogen family, making it a -3. That means altogether I have a -6 charge from the anions. I have to have a +6 from all of my cations. Well, I've got 3 of them to make up that +6. That means each one of these is a +2. So what I'm dealing with is copper 2 ion and the phosphide ion. So the name of this compound then is copper 2 phosphide. And there's naming type 2 binary ionic compounds. Make sure and watch the next video where we're going to put in some polyatomic ions.